Hey guys, Mr. McKinney here, just going through a last video for Unit 5. We're going to talk about how to maximize profit, and then we're going to go over the extreme value theorem real quickly. This is just a specific example of optimization. And again, optimization just means you're trying to find the max or a min for a given problem. So a common business example is trying to find the maximum profit or extreme profit. So extreme refers to the max or the min. Usually if you're in business, you want to maximize your profit. Now profit is going to always be calculated by finding the revenue, subtracting the cost. So the revenue is the amount of money you're earning by selling your item or whatever, and the costs are what it costs to make it. Now keep in mind that extrema happen when the first derivative is 0 or undefined. And we're going to be focusing on when the first derivative is 0, because in real life business examples, you're not going to have undefined pop up very often. So I know that profit is equal to revenue, take away costs. So I want to know when the first derivative of profit is 0 or undefined. That's the possibilities for where I could have a maximum or a minimum profit. So I'm going to take the derivative of p, which would be p prime of x. And then I'm going to take the derivative of r and c. So r prime of x minus c prime of x. So the rate of change of the profit is equal to the rate of change of the revenue minus the rate of change of the cost. Remember, the derivative is just another way of saying the rate of change or the slope. And I want to know where the derivative is equal to 0. So I want to know where r prime of x minus c prime of x is equal to 0. And if I'm going to solve this, I'm going to figure out where r prime of x is equal to c prime of x. This is the main thing that we need to take away from this part of the video. That if we want to find out when the maximum profit happens, we're going to take the derivative of revenue and cost, and we're going to set them equal to each other. Now, when we solve this, the solutions are going to be the possible extrema. Remember that you still have to look for p prime either going positive to negative. That's going to be what we're looking for maximum profit, or if I went from negative to positive, that would be looking at minimum profit. Now, we're not going to go through any examples all the way because, again, the main thing that you need to take away from this video is just that you are going to find the extreme profit, the max or the minimum profit, when r prime of x is equal to c prime of x. So the rate of change of the revenue is equal to the rate of change of the costs. And let's look at a couple of examples that have already been worked out. So for example, we've got this graph here. The red one is my revenue. So we start out with lower revenue and then higher revenue. And then the blue graph here is my costs. Now, the break-even point is when the costs and the revenues are equal. So that's when my profit is 0. Because again, profit is the revenue minus the cost. Now, that's going to happen when the rate of change of revenue and cost are the same. Now, you're going to have to look at whether the revenue was greater than the cost or if the cost was greater than the revenue to figure out if you're at a maximum profit or if you're at a maximum loss, aka a minimum profit. So again, notice that at the two possibilities for extreme profit, either max profit or minimum profit, the derivatives of cost and revenue are equal to each other. So the slopes of the cost and the revenue are equal here, and the slopes of the cost and the revenue are equal here. So those would be the possibilities, and then you would plug values back into your original equation, your profit equals revenue minus cost, and you can see whether you were at maximum profit at this point or at this point. Or you can look at a graph of p prime and look for when it's going positive to negative. So here's another example that's been worked all the way out. So we've got r of x equals 9x, so our revenue is always 9x. Our cost is a cubic function. Is there a production level that maximizes profit? So if we want to maximize profit, then we're going to want to go through and, yeah, there we go. Okay. So we're going to find the derivative of each of them and then set them equal to each other. So the derivative of 9x would be 9. The derivative of our cost equation would be 3x squared minus 12x plus 15. Set them equal to each other, and then we're going to end up having to use the quadratic formula to get our two x values. So these are the possible maxes or mins, and then we're going to look at the graph to figure out which one is the actual maximum for profit, where the revenue was higher than the cost. So I would hit pause and read through this a little bit more in detail. But again, the main thing to take away is that maximum profit, let's see, where am I? So, whoops. Maximum profit is going to happen when R prime is equal to C prime. I don't know why my pen's not really working right now. Okay, so then the last thing I want to talk about is the extreme value theorem. So this is just a really quick slide that we had cut out of our slideshow for this year because we're going to move all the theorems to the end of the year for COVID. But one of the Math Excel questions refers to it, so I wanted to just go over it real quick. The extreme value theorem just says that if f is continuous on a closed interval, then it has a maximum and a minimum. So as long as you are continuous on a closed interval, you have to have a maximum and a minimum. And here's some pictures showing that. So your maximum and your minimum, like the max could be at an endpoint, the minimum could be at an endpoint, the max and the min could be in the middle, they could both be at the endpoints, but as long as it's a closed interval, so as long as it's continuous and it's on a closed interval, it has to have a max and it has to have a minimum. So this is the easiest theorem. It's basically just saying that extremes exist. There will be a max and a min if you're continuous and you're on a closed interval. It has to be closed because otherwise you might have a hole that would preclude a certain value. All right, hope this was helpful. Good luck. Have a great day.